Dehydration of alcohols. Now, one of the best ways, at least in my opinion, to make alkenes is by dehydrating alcohols. Very simple. Notice you have your alcohol, some kind of acid will give you an alkene plus water. One thing you need to notice though, this is reversible. So if you don't have any water and a bunch of acid, the alcohol will dehydrate to the alkene. If you have an alkene, a bunch of water, and an acid, the alkene will convert to the alcohol. You can get the alkene from the alcohol. You can get the alcohol from the alkene. Both can happen. Now let's do the mechanism. It's an acid catalyzed reaction. So the first thing you're going to want to do is use your acid. I just draw H+. H+ will protonate the alcohol. And you get this thing here, which I think everyone will agree looks just like water. This looks just like water. This part, of course, doesn't. This part certainly does. Step 2. Now, drawing this mechanism, if I wasn't showing it to students, I would just start from here and keep on going. I would just go here and then keep on going and finish the mechanism. But because I'm doing it for students and I'm doing it for students' notes, I go stepwise. Now, on an exam, if you go stepwise, that's fine. It's just a lot of wasted time. But if you go just start here and then just draw the whole mechanism out, that's also fine. And now the leaving group leaves. This should remind you of something. This is very similar to an E1 SN1 reaction. Leaving group leaves. Now this is different. This step up here, the protonation step, is new, but this is just an E1 SN1 type reaction. The leaving group is leaving to form the carbocation and water. Okay, so you have a carbocation intermediate. Should scream SN1E1 to you. Carbocation, doesn't matter how you form it. Carbocation can do rearrangements. Carbocations can do SN1. Carbocations can do E1. Remember that. Just because we dehydrated an alcohol doesn't mean this carbocation cannot do rearrangements. This particular one will not because it's already tertiary. But given the chance, given the more stable cation, they could. So keep that in mind. Now the final step because this is an acid catalyzed reaction, we use the acid in the first step, and we should at some point in the mechanism get the acidic proton back. So we started out with an acidic proton. Right now we're going to get it back. And you're thinking, well, how are we getting it back? It's attaching to water. Aha, but look at what it's making. It's not making water, it's making hydronium. And remember, acidity is measured by the concentration of hydronium. So we used the catalyst in the reaction, and we got it back. Remember, to be a catalyst, you cannot be consumed in the reaction. You have to be used, but you can't be consumed. You have to be able to go back out of the mechanism and restart it again, which it will be able to do now that we formed a molecule of water. And that's the mechanism of dehydration. Let's see an example. All right, so we have an alcohol in sulfuric acid. Don't worry that it's sulfuric. That's irrelevant. It's an acid. What's relevant is it's an acid. All right, so the first step, let's protonate. Use the catalyst. First step, almost always correct. Form the protonated alcohol, which is essentially going to form water. It doesn't essentially form water. It literally forms water. There we go. Now, we're going to be careful here because this is asking us to predict the products. And I'm going to modify it slightly, predict alkene products. This whole reaction could go backwards to make the alcohol. We don't care about that. So remember now, when given a choice, which now there's a choice, you can deprotonate here and here or here. When given the choice, the more substituted double bond will form if all things are equal. Now there's no bulky base here, so there's no cheating towards Hofmann. So this is probably going to give you the Zaitsev product predominantly. Well, I'm going to draw the mechanism for the other product as well, because it could form both. It probably will. Predominantly, you'll get this. This will be your major product, because it's the more substituted double bond, the Zaitsev product. So this will more than likely be major. But just for completeness sake, and because it's possible to form this. Oops, not there. Let me try this again. So now we're going to deprotonate the methyl to get a different product. The least substituted double bond, or the Hofmann type product. So this one will predominate in this particular reaction. Both are possible. If you did this reaction, you would probably get a small percentage of, or large percentage of the more substituted, and a small percentage of the Hofmann. That's how it would work. All right, guys. Now with that, I want to say thank you for viewing. Good luck and good chemistry. We'll see you soon.